All right, hello everyone. Welcome to week 5. And I think we have everything ready to go for this week. We recall from our last period where we were discussing some odds and ends with respect to some of our mobile data collection applications that we were working through. So I think we resolved some of those. But since this is a newer lab that we're trying, hopefully we have everything down for you here. But nevertheless, I did want to provide a quick overview video for you to share a little bit about where we have come from on Saturday, or our last period rather, week 4 to then week 5, which will be our period here this evening. So on the screen in front of you, you see some of the general overview and objectives as well as online activities. And so really, week 5 is largely about a continuation of application of week 4. So in week 4, we looked a lot with data sampling, sampling strategies, looking at collecting and capturing areas of elevation change. This lab will be very similar for our period this week. Last week we used some surveying instruments and survey gear, which I think you'll find that that's very accurate. So this week we're using the same style, the same application in a sense, to capture areas of elevation change, but we'll be doing that with our civilian grade GPS or our mobile devices using ArcGIS, or the data collector for ArcGIS, the new collector application rather. So on the screen, you'll also see the agenda, which we'll look at soon, but the objectives are continued on to really continue fundamentals, data collection strategies, and of course, really a big one for us in the end, at the end of this lab or at the end of our activity, assignment number 5 will be to explore and discuss challenges and limitations with respect to GPS. And one of the big things I think you'll find is that GPS has obviously some X, Y, or horizontal based error associated with it, but its vertical can oftentimes be even more than that, just because we don't really have any satellites, any satellite data coming from underneath us. So we're limited really just to what's above us, giving us our XY horizontal error, followed by whatever limitations we have with respect to our vertical error. In other words, our Z axis would be our vertical. So we'll be working with identifying different types of error with the GPS. So recall back in week 3, we'll want to go back to week 3, or you will want to go back to week 3 and take a look at some of the readings associated with GPS error, because that you may want to leverage in some of your lab write-ups and discussions for that. So really weeks 3, 4, 5, 6, the content a lot with the GPS and some of the principles and protocol for our data labs will be pretty similar. So don't forget about going back to reviewing the robustness of the week 3 content just to familiarize yourselves with GPS sources of error. Also in week 5, there are a couple of short, I would call them seminar videos. And to you, the first one that you're looking at on the screen here will correspond to an ESRI seminar video on using workflows with ArcGIS with the data collector for that, data collector for ArcGIS. And so there'll be some things in there that we'll use for lab, but mainly it's just a bigger picture awareness of the new collector for ArcGIS. There's a classic version and a newer version that we'll be using for this class. Of course, there'll be some limitations, as we mentioned, between iOS and Android users. iOS people will probably have it a little bit easier going, at least with the first version of the collector release. But in a sense, the new collector is probably a lot easier. It seems like it's a little bit more straightforward, a lot less clunky in terms of general workflow. And that's where the seminar that's provided here for you hopefully give you a bigger picture of how the collector application is being used in greater arrays, greater opportunities out there. So it is a freebie one, but just general background. Then you'll see a small section here on class content. Some of this ties into GPS accuracy. Again, going back to week 3 a little bit, but more or less looking at what's going on with some of the accuracy related to our vertical with GPS, because that's what we're really going to be working through in this lab, is trying to explore and identify some of those limitations, particularly with our Z or or elevation axis. So some of those links correspond to that. And then also some of the other links down below here that I'm referring to right now, those are really going to take you through a little bit more of what's new with the new collector for ArcGIS. Of course, there are all kinds of collection devices out there. Trimble has some. Those are certainly not off limits. Years gone by, we've looked at Trimble applications as well. So maybe that's something you could do for a final project is explore the user functionality or the intuitive nature of using several different types of data collection applications. That's something certainly that you could do as well for a final project in the course. But these are background informational links to help prep you for understanding a little bit more about what's going on out there with the classic collector to the new collector. Then there are a few short videos here, YouTube videos on little 5-minute modules that are really pretty clear cut and I think pretty informational on taking you through a little bit of a recap on GPS sources of error, just to get you prepped again on that. And then there's a longer video here on working with Collector for ArcGIS. So the first seminar was a little bit of how we can implement or integrate some of the workflow processes to go out and collect field data and whatnot. This is a much more robust, bigger picture concept of what Collector is all about. All right. And as I mentioned, where it says Android users here, if you need another GPS app to record elevations, this might be a good one. This is purely a suggestion. For our lab this week, for activity assignment number 5, we'll be going on collecting GPS points. And part of the new collector will work really well for iOS users. So I think majority of the class had iOS devices. So you all will be pretty pretty clean cut, crisp, no problem. Android users, what you will have to do is that the collector app does not feature Z collection capability quite yet. So what you will have to do for this lab activity 5 or lab outside this week will be to research or study and find another GPS app where you can use that while you're out at your points to record the Z values. So you'll be using the collector app to record XY location, but you'll also have to determine the Z value. And while the Z values for so many apps are not going to be really correct in nature, well, arguably no Z value will be correct, but some of the other apps that are out there may be pulling data from another source. So we're not sure really how accurate that is. So we'll have to work with that given its limitation there. But the one shown here is a pretty decent one. EXA Tools, it's a free one. It does seem to work pretty well. I don't think it's going to give you decimal values like the iOS collector app will, but nevertheless, it'll be something we'll just have to work around. Or you could choose to use my data for the lab that'll be provided here in Winona. So you can use that and follow along with those informational steps for the lab down below here, which let's take a look at now. So our activity assignment number 5 will be related to our mobile GPS lab. And so this lab will involve taking out your mobile device, whether that's an iOS or an iPhone or Android of some capacity. And what you'll be doing with that is loading the collector app onto your device and then going out in the field to an area of your choice and collecting some elevation readings. So that might be 30 to 40 to 50 elevation points. That'll really be something you'll have to think about as part of your sampling strategy to capture areas of elevation change once again. So what we'll be doing is capturing areas of elevation change with our devices using ArcGIS Collector. And then what we'll be doing is comparing our surfaces that we generated from our elevation points just like what we did with the total station. So with the total station, we had all of our elevation points. We created a DEM out of that, a digital elevation model with some contours. We'll be doing the same thing, really, just using our elevation data from our ArcGIS collector. And then we'll be comparing our surfaces to some known topographic elevation data from a web resource, a website called MinTopo. So I'll be taking you through here in another video on how to go through that lab demo. And that lab demo also will mimic what you see here on the screen related to the iOS process for your lab and then an Android process. Largely, they're similar. The only real difference is Android users, you'll have to go and find another app to collect some elevation data or determine that elevation data in some other manner. And but nevertheless, they should be pretty well straightforward. I did try to provide, this is from the agenda, the class agenda for week 5. And so just to step through that a little bit, part of the lab or our assignment for this week will be related to finding a study area. And if you have cellular availability, that will really be a key component for the new collector app. There are, I think, some background ways that you can go in and cache maps, but it seems like it's a little bit clunkier, a little bit not quite as user friendly. If you are in an area where you can't obtain cellular availability, contact me and then we can come up with another plan and maybe revert you back to the classic collector app where caching maps are a little bit easier. And so there are some options and solutions for that too. So find a study area, similar in size to maybe what we did with the total station outside in Minneapolis or Winona. It does not have to be a huge area, but one thing I would encourage you to do is find some variability in the topographic characteristics. So you might find an area where there's a really long slope or where there's a lot of ups and downs that are going to be maybe 10, 15 feet of change or something like that, so we can actually try to model that elevation to the best of our ability. If it's relatively flat, we might have a tough time tying into some of the known elevation data that we'll be getting from our min topo site that I'll be pointing you to here in just a little bit. So once we define our area that we're going to survey or collect areas of elevation change, what we'll be doing, just as it says here with number 3, is we'll be firing up our collector app on our phones. In other words, activating our GPS and then going to locations and collecting points every so often where there's areas of elevation change occurring. And so in the iOS systems, our Z values, our X, Y, and Z will automatically be collected. Android users, your X and Y will be collected, but you'll need to use that alternative, some secondary GPS application to record your elevation for that. And you'll go through your study area, collect those points of elevation change. And then, as with number 4 here, these are just big picture items 1, 2, 3, 4. I have the actual more boiled down version step by step right up in here for what to do, up in our iOS processes and Android processes. So the items below that we're looking at on the screen right here, purely big picture, general guiding principles for us. So after we're done collecting that data, we'll generate a couple of surfaces from those. So one will be your DEM that you'll generate off of your elevation points. And then 2, you'll generate a new shapefile like you do with total station, but with contours. So remember, contours connect points of equal elevation for us. And that's kind of where I'm taking you through here in 1 through 5. Next, we'll go to this site right here called Min Topo. Maybe we can go to that just to show you briefly what that looks like. I know I have it on the screen here, but we'll see if we can pull up another version of that. So you might have to try this again. Okay, let's go back here. We'll give it another whirl. All right, so it's not liking, so we might have to copy that out, but essentially it's going to take us to a location that looks like this. Actually, your landing page will look like this. Let's just pull that up so you can see that. So this will be the page that you will land on ultimately. And actually, it might even be this page. Oop. Well, nevertheless, we'll get into min topo here. We'll come back in another session and show you just exactly what that looks like. And select out our study area, and I'll show you that in a demonstration. And then we'll be comparing our surface, our DEMs, from our data collection to that of the data set from min topo. We can use our DEMs and our contours or some combination thereof. Essentially, what we want to do is to explore how our how our GPS vertical elevation is going to give us a DEM surface that may not be congruent with what's actually there. So from you going out there in the physical space collecting that information, you'll probably be able to see just in sharp contrast how different those surfaces being generated from your GPS really are from going back to what we had, which was really pretty accurate with our total station, to now GPS, which bodes a lot of problems or brings in a lot of error, particularly with our z-axis. So we'll be able to kind of compare that with our min topo site. So you're free to use whatever site area that you want to explore that, so long as there's probably some type of a nice topographically rich area to explore. So some things to think about when you're comparing your surfaces, and I'm writing number 8 and 9 here on the screen if you're following along, would be related to these things. How do we know what accurate is ultimately? So when we're dealing with data, what are benchmark surfaces? Not benchmarks of 100 that we think of that, but what are known elevations that we can tie back into our data to start to say, I'm off here, or what really defines accuracy? So be kind of thinking about that. And how accurate are your two surfaces? Are they similar in some areas? Are they different in some? Some may depend on the accuracy of your GPS signal. If you're under some tree canopy, which at this time of year there's probably not going to be a lot, but if you're down in a valley or something like that, some of your horizontal accuracy will be compounded then with your vertical accuracy just from satellite limitation, perhaps. So be thinking a lot about those errors, those GPS errors, and how they may be creeping in to creating surface error problems when we have our DEM models built. So give some of these some thought as you're thinking about your lab write-up and going through your lab. And another illustration here I made with respect to letter F right here. So you could go, for folks in Winona, out into the area where you collected our total station. Minneapolis folks, you likewise could go out in front of Martin Depur and St. Teresa's and collect elevation there. You're probably not going to get a lot of topographic variability. So in a sense, when you're trying to generate your GPS DEM surface layer off of your ArcGIS data collector points, you're not going to find min topo. In other words, the min topo data that we referenced up here, you're not going to find that data to be as accurate. So what you may want to do if you do decide to take your GPS out to either of our total station areas that we surveyed is, instead of comparing it to the min topo, you may want to just use your total station surface that you created, because that's going to be far more accurate or precise at that level than min topo will even have data for. So just wanted to throw that out there. That's what I meant when I was referring to letter F. Otherwise, the lab write-up process will be very similar to what it was that you used for Pace and Compass lab a few weeks ago, as well as Total Station just last week. And if you would like to work and partner up with someone on this lab, go out and collect data together. You can use one person's device if you wanted, and then make sense of that data together and write up your lab together as well. So if that is the case and that's what you choose and decide to do, just submit one lab report for the team that you're working with. If you're working with one or another person, so it might be a group of two or three. So it's all what works best for you, in your schedules, but some people work better in groups, so we want to provide that opportunity for you as well. And referring to the agenda, probably should have done this first here, perhaps, but in taking a look at the agenda for this week, as I mentioned, there'll be the weeks of content really spanning weeks 3, 4, 5, 6 will all really be related. So do go back and span some of that GPS material just to brush up on. If you did review it all back in week 3, great. Go back and brush up on it. If you didn't get a chance to, here's your chance to kind of go back through some of that. And then the assignment activity 5 we looked at, I'll be posting a quiz this week as well here once we have all of our goodies up and ready to go. So look for that to be coming as well. So otherwise, the lab we explored a little bit there. So you have to let me know if you have any questions on this, or for that matter, total station. And as we did spend a lot of time on our week 4, so I know we uploaded that week pretty heavy. So this week we're focusing mainly just on continuation of GPS and how we're collecting areas of elevation change using collector for ArcGIS, then comparing those surfaces we create to known elevation from our min topo resources. So if you have any questions on any of this, please reach out and give a holler. Otherwise, look for another integrity session very soon related to a lab demonstration of how we'll be doing activity assignment number 5.